Now, at this point, we have already talked about how to find the point estimate for the confidence interval for a parameter, and we already know from our experience forming confidence intervals for population means that to write a confidence interval, the two things that we need is first and foremost, we need a point estimate. We know how to find that now. We found that in the last example. It's our sample proportion. And once we have the point estimate, we need to know what the error is. So we can move the error to the right and the error to the left by adding and subtracting it from our point estimate. So those are the two things that we need in order to form a confidence interval for a parameter: a point estimate and the margin of error. We've talked about how to find the point estimate. Now we're going to talk about how to find the margin of error. And if you remember, even back from the last couple of lessons, the formula for the margin of error was not the same as it was in lesson 18 as it was in lesson 19. Right? We had different formulas depending on whether or not we knew that population standard deviation. Remember, in this lesson, we're not talking about averages. We're not talking about means. We're talking about proportions. And the formula to find the margin of error for a proportion, if you have a certain level of confidence, remember 90% confident, 95% confident, so on and so forth, we can find those critical values looking at the bottom of the standard normal table. We take that critical value and then we multiply it by the square root of p hat multiplied by q hat, which is all divided by n. And this formula is only valid if both of the following are true. N times p hat is greater than or equal to 5, and n times q hat is greater than or equal to 5. So now that we know the formula to find the margin of error E, we just talked about that formula, and we also know the conditions that we need to check. If those conditions are not true, we will not be able to form a confidence interval for a population proportion. We need both of those things to be true. Now let's outline the steps that we need to follow in order to construct that confidence interval. And you may have noticed I did have the wrong words up here, but I did fix it. We are constructing a confidence interval for P, the population proportion. So the first step is we need to identify the sample statistics N and X. That's what we did in the first example, where we found what number of US adults used Facebook and what number of people were included in the sample, because we need both N and X in order to calculate our point estimate P hat, which is equal to X divided by N. Once we have our point estimate, we need to check that we are even allowed to go on and use the formula for the margin of error, and that will only be true if both NP hat is greater than or equal to 5 and NQ hat is greater than or equal to 5. And off to the side here, I will write, once you know P hat, you can find Q hat because Q hat is 1 minus P hat. We talked about that with the percentage of Americans that smoke cigarettes, how the total percentage of those who did and those who did not needed to add up to 100. So if we're working with the decimal values, they would need to add up to 1. Then we will need to go on and find our critical value, Z sub C. We have seen many ways that we can do that. We can use StatCrunch, we can use a calculator, or perhaps what I think is the easiest way is that you could use the standard normal table, because at the bottom of the standard normal table, that printout that's linked in lesson 14 is a little summary of all of the critical values that we have there. So you could just use depending on whichever critical level of confidence that you're asked for. And for the most part, you'll only be asked about 90, 95, or 99. So you'll have the critical values that you need. Once you have your critical value, you will then go on to find your margin of error using the formula that E is equal to Z sub C, that same critical value, multiplied by the square root of P hat times Q hat, all divided by N. And then once we have our margin of error, we are able to go and find the left and the right endpoints of our confidence interval. Remember, for this confidence interval, we're starting with the point estimate, which was P hat. And to find let's start with the left endpoint. To find the left endpoint, we're going to take that margin of error and we're going to subtract it and move that distance to the left. So the left endpoint is P hat minus E, the margin of error, and the right endpoint we're going to move to the right, whatever that margin of error is, and that will be P hat plus E. And then once we have our left and our right endpoint, our entire confidence interval is the interval p hat minus e, ending at p hat plus e. So now that we've seen how to construct that confidence interval, let's go look at an example where we construct one for a population proportion.